All right, welcome back. If you're here, I hope that you already watched my video on product and quotient properties, what those actually look like, defining base and exponents, because you're definitely going to want to understand that before coming here. But this specific slide is going to be on how to use the product property. Remember, that means if things are being multiplied together. Notice how all of my examples are being multiplied. First thing you want to recognize is, do they have the same base? So my first example here, they have a base of x. That's a good thing. That means that we can combine them together. The product property says when common bases are being multiplied, you're going to add the exponents on top. Think about it this way. X to the fourth is x times x times x times x. Writing it down 4 times. X squared is x times x, writing it down 2 times. So think, how many x's are being multiplied here? You should come to the conclusion that there are 6 of them being multiplied. That is why we are allowed to add the exponents. If we have 4 of them here and 2 of them here, we have 6 total. Same thing for my next example. We have a common base, y, so we can go ahead and combine these into one exponential expression. So we have 7 y's being multiplied here and 4 y's being multiplied here. So think, how many do we have total? Well, 7 plus 4 is 11. For this next set here, I just wanted to show you an example where it had numbers in the front. So we have a 15 and a 3. I'm going to ignore those for a second and just look for my like bases or my common bases. So the only thing that's the same between these two things are my bases m. So I can go ahead and combine those together. Think I have 8 m's being multiplied here and 3 m's being multiplied here. So think, how many m's do we have total? Then we can worry about the extra pieces. So this 15 and this 3, they are not like bases. Treat those exactly as you would normally. This is saying, what is 15 times 3? You should come to the conclusion that that is 45. And this n is just a floater. It's just an extra piece. We're not going to do anything with it because there's only one of them. So we're going to say still that there's only one of them. So we did 15 times 3 is 45. M to the 8th times m to the 3rd meant we had 11 m's total, and then just reattach that n at the end because I only have one n being multiplied here. There's an invisible 1 right here. You don't really need to write it though. Same thing down here, n times n. We talked about this in a previous slide. So that just means we have one n here, we have another n here, so together we have 2 n's. You could put, again, invisible 1's at the top. Lastly, I have a common base of 3. Please do not come to the misconception that you have to multiply 3 and 3 together to get 9 and then add the exponents. You don't want to do this. Just say, all right, how many 3's do I have here? 2. How many 3's do I have here? 5. So how many 3's do I have total? 7. Don't actually try and multiply 3 and 3 and then say 9 to the 7th power. You're going to realize later on that that's going to get you an incorrect answer, and you don't want to do that because this is already 3 times 3, and this one is 3 times 3 times 3 times 3 times 3. So 3 is being multiplied plenty of times. Don't change it to a 9. Keep it the 3. Now let's look at the exact same examples on the next slide, but instead of being multiplied, they are being divided. So this is the opposite. Instead of adding my exponents together, we're actually subtracting. So this is saying we have 4 x's here and we have 2 x's here, but we're going to divide them out. It's the same thing as like canceling. Let me see if I can write out an example like this. I do, let's try this. So we have 4 x's on the top, and then we are dividing by 2x's on the bottom. Unfortunately, I can't do the divide by line in this program, but bear with me here. So 4 on the top, 2 on the bottom. So think about this like canceling out. So anytime you have something on the top that is the same as something on the bottom, you're not doing any extra adding or subtracting over here. You can actually cancel out. So I'm going to do that. I'm going to say, all right, well, I have an x on the top and the bottom, so I'm going to get rid of them. I have another x on the top and the bottom, get rid of them. So all that I have left are 2x's on the top. So that is actually how I got, for this answer, x squared. That's just kind of explaining why we subtract. So 4 minus 2 got me 2. Same thing here. I have 7y's on the top of the fraction, 4y's on the bottom of the fraction. So if we cancel those out, that's the same thing as subtracting. 7 minus 4 gets me 3. So I'm left with only 3y's after canceling. In this expression, my common bases are my m's again. So I have 8 m's on the top being multiplied and 3 m's on the bottom being multiplied. So if we cancel those out, we get 5 of them. But remember, we have this 15 and the 3 in the front. You actually have to follow the rule there. Think, what is 15 divided by 3? And you will get 5. So 15 divided by 3 is 5. M to the 8th divided by m to the 3rd is m to the 5th because I subtracted. This one here, we have n divided by n. Again, think what little exponents go up there. So this is like n to the 1st, n to the 1st. Well, what is 1 minus 1? You get 0. And we will actually talk later about what the exponent of 0 means. I'm not going to bring that up now. Final example, 3 squared times, I was supposed to be divide. My apologies. This is division symbol right here. So 3 squared divided by 3 to the 5th. Same thing here, we're just going to get a negative answer. So we only have 2 3's on the top and we have 5 3's on the bottom of the fraction. So when we do canceling out here, 2 minus 5 is actually a negative exponent. So this is going to be 3 to the negative 3rd power. That is another thing that we are going to be addressing in a later video. What do we do with negatives? I would like you to try these for yourself. They're a little bit trickier. There's more to it, but you should be able to use the ideas that I told you earlier. Just make sure you're looking for common bases before you do any of your addition or subtraction steps. So go ahead and pause the video because I'm about to give you the answers to these. See if you can do them. Give it a shot, check the answers. If you didn't get the right answer, try and figure out how did I get my answer. All right, please come prepared tomorrow in class. Bring any questions that you may have. Best of luck.